I want to count how many bricks I have for each color and shape on my table here. I've already split them up into groups for colors and shapes. Now I need to just go through and count them. This could take a while, particularly if my table has thousands, millions, or even billions of bricks on it. But I know that I'm going to have a maximum of 3 different colors, green, red, and blue, and at most 3 different shapes, cubes, cuboids, and these star things. So at most, I'm going to have 9 rows in my output. If this is a query I'm going to run often, I can make the process a lot faster by creating a summary table storing the count for each color and shape. So I can just read this rather than all the individual bricks. But in order for this to be useful, every time I change the data here, for example, add another red cube, I need to go to my table and increment the corresponding counter. This adds a lot of processing and code you need to write to keep that summary table in sync. Luckily, there's a way for the database to do all of this automatically. Materialized views. Before we jump into the details, a quick note on the difference between normal views and materialized views. A regular view stores the text of your SQL statement, giving you a reusable statement. When you query the view, it's exactly the same as if you ran the query within it. A materialized view, on the other hand, stores the result of the SQL statement. When you access it, you get this pre-calculated result. The database does not access the base tables themselves. This is something that can make your SQL statements orders of magnitude faster, particularly if you have a statement that reads millions or billions of rows but returns just a handful. So instead of creating a summary table and writing code to keep it up to date, you can create a materialized view storing the color and shape counts for the bricks. So after creating the materialized view, we only have 9 rows to read, which we can get all in an instant. Whereas if we go to the table itself, the query could take seconds, minutes, or even longer. And now for the real magic. If your application contains SQL that matches that in the materialized view, the database can automatically read the materialized view instead of the base table via something called query rewrite. So you can get huge performance advantages without changing any code. And this also applies for queries which are similar to that in the materialized view. Say, instead of counting the bricks for each color and shape, you just want to count the number for each color. Well, we can get this information from the materialized view by summing up the shape subtotals for each color. This means one materialized view can give you large performance gains to many SQL queries in an application. But in order to be able to do a query rewrite, first you must enable it on the materialized view. Also, and more importantly, the data we have stored in the materialized view must exactly match that what we would get from running the query against the table itself. If we change any information, say add another red cube, there is now a mismatch between the table and the materialized view. So the database will no longer do a query rewrite. To fix this, we need to bring the materialized view up to date. You can do this by calling dbms_mview.refresh. This will then rerun the query in the materialized view and store its results. But this could take a while. After all, the reason you use a materialized view is you have a long-running query that you want to make faster. So, how can we make this process faster? Well, every time we make a change to the table, we can record it in a log. For example, if I add a red cube and remove a blue one, what we can do is write that down. Say, +1 red cube, not very good at writing here, -1 blue cube. Now, when I refresh the table, instead of having to go through and count them all individually, What I can do is just look at these changes. So I can say, got +1 red cube, so I'll increase that to 8, and -1 blue cube, so I can take that down to 12. I can then empty these changes out of our log here, ready for the next thing. This is the basis of something called fast refresh. Record the changes and apply them when we do the refresh to the totals. In order to be able to do this, we need to create a materialized view log. Do this with the statement create materialized view log on the table you want to track changes for. To ensure maximum performance and refresh possibilities, you'll also want to include the primary key of the table, the row IDs, the sequence of changes, the commit SCN for the transactions, and a list of the columns you use in the materialized view. Finally, you also want to include the new values for these columns. With the log in place, we can now do fast refreshes which take microseconds. So it is much easier to keep the materialized view in sync. So at this point, you might be wondering, why not just always do fast refreshes and create the log when we create the materialized view? Well, there are some types of query where you can't just take a look at the list of the changes and apply them to the totals and still get the correct answer. For example, instead of counting the rows for each color and shape, say we count the rows for each color and the number of distinct shapes for each. So, after creating a materialized view with these new subtotals, if I try and add a new brick to the table, say my blue cube here, I don't know, is this cube in this count of 2 different shapes for blue? There's just no way to know that other than to go back to the table itself and count the distinct shapes. There are many other types of query which have this kind of logical restriction, where you can't just look at a list of the changes and figure out the new totals. There are also many technical restrictions which prevent fast refresh. If you want to know the details of all of these, check out the docs, which has a big list of them. Links in the description if you want to know more. But there is a much better way than reading through the documentation. The procedure dbms_mview.explain_mview tells you why a materialized view is fast refreshable or not, and what you need to change to make it so. Assuming your query does support fast refresh, you can change the materialized view to do this. Even better, you can get the database to update it automatically by making it fast refresh on commit. This is really handy because it means the materialized view is always fresh. It never goes stale. But it does add a little bit of extra processing to all of your transactions for those tables. In write-heavy applications, this may add too much stress to your database. So you may be forced to call the refresh procedure on a schedule. So there will be brief periods of time when the materialized view is up to date and query rewrite can happen, followed by chunks of time when it is stale and query rewrite can't happen. So SQL performance could flick between ultra fast and ultra slow. This is the kind of thing that drives users crazy. People don't like slow queries, but if it's predictably slow, say it always takes 5 seconds, they'll live with it. Something that flicks seemingly at random between half a second and half a minute is the kind of thing that will very quickly get them coming for you with axes. So what can we do about this? Well, there is a trick. You can set the query rewrite integrity parameter to stale tolerated. This means the database can use the materialized view for query rewrite even though the data is out of date. Now, you may be wondering, why would we ever want stale data? Imagine you have a materialized view you just refreshed. 1 second later, a user runs a query in the materialized view, but there's been changes to the tables, so it runs against the base tables. This query will run for 5 minutes. 1 minute after the first, another user comes along and queries the materialized view. At this point, the materialized view is 1 minute out of date, But this query completes in 1 second. The first user still has to wait another 4 minutes to get their results. So even though the second user started their query later and used, technically, out-of-date information, they waited less time and their answer is 4 minutes more up-to-date than the first one. So, stale data can be useful in some cases, but this is something where you need to work closely with the data consumers to ensure it meets their needs. Or, in Oracle Database 12.2, there is another option: real-time materialized views. These take a stale materialized view and, at query runtime, apply the changes in the log. This means you no longer need to refresh the materialized view in every transaction, so you avoid the hit there. But you still get good performance gains for those queries. This hybrid approach can give a best of both worlds outcome, provided you still do the refreshes regularly to keep the materialized view log small. To recap, materialized views are an amazing performance tuning technique, particularly for queries that read millions of rows but return just a handful. For example, counting how many orders your company received each day. They can also be useful for things like pre-calculating joins and other types of complex query. Provided you can define your materialized view as fast refresh on commit, then the data always stays up to date, and the database can do a query rewrite, swapping in the materialized view instead of reading all the data from the table itself. Sadly, there are many restrictions that prevent fast refresh. If you hit these, then either you need to rethink your queries or deal with stale data. Thanks for watching. The rules for fast refreshable materialized views are complicated. Check the documentation for full details and subscribe for more SQL tips.